this meeting, we will tackling, or we will study the eccentrically loaded foundations. Okay. Basically, we apply moment, and then moment at a, and we apply moment, vertical loads, no, and then additional of it, no, meron na po siyang eccentricity, okay, to consider. Okay, so before, the Terzaghi, he only study about the properties, or the what do you call that, the behavior of our foundation only. Okay, and then the second topic, no, we study about the considerations of the effect of water table in our foundations. Okay, and then for the third topic, it is a combination of the first two topic, and then we also includes the eccentricity. Okay. So if you have a questions, no, pwede nyo namang tayo mag-interact. Okay? So for these, in several instances, no, as with the base of the retaining wall, foundations are subjected to the moments. Okay? As I've said before, no, we also consider the moment. Okay? In addition to the vertical load, not only before in our lesson 1 and lesson 2, okay, it is only, we consider only the vertical loads. Okay, so we can see there in the figure 3.13a. Okay, in such a case, the distribution of pressure by the foundation on the soil is not uniform. Okay, so the normal distribution of pressure is, we can see later on. No, for lesson 1 and lesson 2, no, we only study, no, the foundation with respect to the normally distributed. Okay, but for this time, no, because of the effect of its movement and its eccentricity into the foundation, no, the distribution of the loads uh, are not going to be normally. Okay, it would be a trapezoidal. Okay, or it would be a vertical. No, it would be a triangular distribution. Okay, so we will consider this distribution, and then we will transfer it to the normally distributed. Okay, so parang kung triangular siya, no, we will solve it with the triangular, and then later on we will convert it to the normally distribution. Okay, this would be the figure for the eccentrically loaded foundations. Okay, as I said before, no, there is a applied moment there, no. Meron dito po sa letter A natin, may applied moment, and also the vertical load. Okay, and the base times the or the width or times the length of the foundation. Okay, at a given depth. Okay, for the eccentricity is, for if the eccentricity is b, or less than b over 6, or the width of the foundation over 6, okay, the distribution would be trapezoidal. Okay, because there is a q minimum there, or the effective stress minimum, and there is also a effective stress maximum. Okay, but no, if the eccentricity is greater than the width over 6, okay, it would be a triangular. Okay, if that instance, no, will happen, okay, there is no q minimum, and there is a q maximum. Okay, and then for letter B, okay, there is a vertical load there at a distance E, okay, to the center of the foundation. Okay, either it is the eccentricity. Okay, so this would be the what do you call that? The distribution, no? If we see in the top, okay? Kapag tinignan natin yung top view niya, okay? So, you can see, no, yung kanyang width, it is not the whole B now, okay? The width, it is the addition of the two, okay? The B prime there, okay, yun na yung nabawasan ng kanyang eccentricity, okay? Plus the 2 times the eccentricity, okay? Nakikita pa lamang natin diyan, no, na there is a effect, no, of our eccentricity to the given width or length of our foundation. Okay? Later on, makikita natin sa solving, no, on how to understand well yung kanyang pressure diagram. Okay? So this would be the equations that we will be using later on. For Q maximum, no, it is equal to the uh, vertical load divided by the width times the length of our foundation, or it would be the area, no, of our foundation, plus the 6 times the moment, no, the moment applied or the moment that was used in the foundation, divided by the B squared times the length. Okay? That would be for the Q maximum. And for the Q minimum, no, as we can see, no, the difference only for the Q maximum, it would be the sign convention. Okay? So, magiging negative lamang po siya. No? Instead of positive, no, it would be negative. Okay? Ah, nakuha niyo po ba yun? Nakuha niyo po ba? Okay. Wherein, the Q there, no? Yeah, this is the total vertical load that was applied in the foundation. And the M, it is the moment on the foundation. Okay? For the figure 3.13b, no, as we can see before, no, doon sa figure na pinakita ko kanina, with respect to the eccentricity, okay? It shows first system equivalent, okay? And the eccentricity can get as E is equal to moment divided by the total vertical load, okay? By substituting E to this formula, okay, dito sa Qmax and Qmin, okay, the Qmax mu, it is equal to the Q over B times L, okay, times 1 plus 6E over B. Okay? Nilabas na lang natin yung common sa kanila. Okay? For Q min, it would be the same, no? The only difference of it sa Q max, it is the sign convention. Okay? For Q min, it would be Q divided by B over L times 1 minus 6E over B. Okay? So this is the concept for that. Okay? Now, there are three cases for calculating maximum and minimum cases. Okay? According to the values of its eccentricity and the width of the footing divided by 6. Okay? This would be to maintain the minimum pressure that is always greater than or equal to 0. Okay? For case 1, okay, if the eccentricity is greater than, okay, B over 6. Okay? Mas malaki daw po si eccentricity, yung distance ng kanyang eccentricity, kaysa sa width of the footing divided by 6, or 1/6 of the width of the footing or the foundation. Okay? The Q maximum that we will using, no? It is Q over B times L, okay, times 1 plus 6A over B. Okay? And for its Q minimum, no? Yung instead of plus doon sign, it would be minus sign. Okay? So, when eccentricity is less than the 1/6 of its width, no? The value of Q minimum will be positive for its compression. Okay? Dapat po yung kanyang Q minimum would be a positive kapag, in an example, kapag ito ay compression. Okay? If the centricity is in the L direction or in the, um, what do you call that? In the axis of the L, no? Ang gagamitin natin, no? If eccentricity is less than 1 over 6 of the the length, no? The Q maximum with the same, okay? And the Q minimum is also the same. Okay? Pero, ang gagamitin lang po natin ng kakaiba dyan, okay? We will be using the length of or the size of its length instead of the letter B. O, this one, no? Okay. Yun yung pagkakaiba niya lang. If the problem is asking or stating that the axis of its eccentricity acts on the length direction. Okay? And for case 2, if the eccentricity is equal to the 1/6 of our width, okay? The Q maximum, okay, would be the same doon sa Q maximum ni case 1, but our Q minimum, okay, wala nga po siya. Okay? It would be 0. Okay? Take note of this, that when the eccentricity is equal to the 1/6 of our width, no, the value of Q minimum will be 0, because the reason of that is there is no compression and there is no tension that reacts on the foundation. Okay? So this case is a critical case, but it is a accepted. Okay? Accepted po siya. Okay? If the eccentricity, okay? If the eccentricity is in the L direction, okay, in the axis of the length, okay, and if the eccentricity is equal to the 1/6 of the length, no, the Q maximum would be the same doon sa less than L over 6, okay? And then the Q minimum, ang difference lang po niya ay the Q minimum will be 0. Okay? So, 0 po yung kaya nun. Okay? So, for case 3, no? If the eccentricity is greater than the width over 6 or the 1/6 of its width, okay? So, we can see in the distribution, no? In the figure 1, okay? The distribution is like this. Okay? If the applied load is at the center of our foundation, okay? And there is also a movement. Okay? So the distribution, the first half, okay, in the right side, okay, the Q maximum is upward. Okay? But it is reacts on the bottom of our foundation. Okay? But for the left side, okay, the distribution is upward, but it is on the top of our foundation. Okay? And then in the figure 2, no, this would be the applied eccentricity na. Okay? May eccentricity na po siya. Okay? And then, okay, we consider na yung kanyang reactions, no? The Q there, meron na siyang eccentricity, okay? The distance between the applied Q and to the Q maximum na bago, okay? It would be the B over 2 minus the eccentricity. Okay? Simple mechanics, mech 1. Okay? So, the distribution for that, no, na it would be changed to triangular. Okay? We will consider na lang at a certain distance, no, magzi-zero na yung ating distribution. May tanong po, Miss Kelly. Okay. Let's move on. Okay. So, as shown in the figure above, no, the value of the Q minimum there, okay, is
Sure, baka mag-gas ako, sure, kasi
Nung go with the flow, sinong go with the flow?
tapos sabi ni Sir, ano,
Walang direksyon ng buhay mo. Go with the flow.
sabi ni Sir,
Malakambani.
sabi ni Sir lang,
No
wala, hindi
fucking
kami
way.
nagkukuhan ng gas.
Nak, kailangan mo talagang mag-diet, ha?
Mhm.
Kasi nararamdaman ko, mataas na naman ang sugar mo. Ang laki na stop.
okay. Thank you, Mr. Kelly. Okay.
Sorry po sir, na-open po yung mic.
Okay lang, okay lang. So, the value of Q minimum there is negative, okay? Because it is tension in the soil. But we can know that soil can resist, no? The soil will not resist any tension. So thus it is a negative. So before sa ating mechanics, no, we consider the tension as positive, okay? And the compression, it is negative, okay? But for what they call this, mm, for yung kanyang talagang reaction for the soil, no? Sabi nga niya, no, the soil cannot resist any, okay? Resist any tension, okay? Therefore, ang gagawin natin sa sign convention ni tension ay magiging negative. Okay? So, must be prevented by making Q minimum, which is equal to 0, at a distance x from the point of A. So, we can see in the figure before. Okay? And to determine the new value of the Q maximum by static equilibrium, no, it would be A is equal to R, or the reaction there, or the area of the triangle, times the length, okay? It is equal sa 1/2 ni Q maximum na bago times the length times the X distance. Okay? So, summation forces, no? The reaction is equal to the applied load. Okay? So, by using moment, okay, summation moment at A, no, it is equal to 0. So, Q times B over 2 minus E, it is equal to the reaction times 1/3 ni given distance. Because, no, 1/3 siya kasi it is a triangular distribution. Okay? But for equation 2, the reaction, it is equal to the Q minus Q, wherein it would be the X distance is equal to 3 times B over 2 minus the eccentricity. So by substituting all the given datas, okay, the reaction therefore, it is equal to the Q, or the applied load, it is equal to 1/2 the Q maximum na bago times the 3 times B over 2 minus L, minus E, should I say, times the length. Okay? So the Q maximum, therefore, it is equal to the 4Q divided by 3L, okay, times B minus 2E. Okay? Again, if the eccentricity rotates in the axis of the length direction, okay, or and then the eccentricity is greater than the length over 6, okay, the Q maximum nu, it is equal to the 4Q divided by 3B times L minus 2E. If we can see, magpapalit lang po yung kanyang placing ng kanyang length at yung kanyang width. Okay? And that one. By using the factor of safety, again, it is equal to the Q ultimate or the applied load ultimate divided by the applied load. Okay? Or the ultimate load carrying the capacity. Okay? Okay, take note of this. No, all of the above equations are derived for rectangular square footing. Okay? Na-derive po siya sa rectangular. Yung sabi ko, before, we can see in the distribution, it would be the trapezoidal or triangular, then it would be shifted to the rectangular or the normally distributed. Okay? But if the foundation, no, is circular, okay, kapag ang foundation natin ay circular, okay, dito na mag-iiba. Okay? Because we will be using the stress formula. Wherein the formula of stress, it is equal to Q is equal to the applied load divided by the area plus or minus the moment times the centroid, okay, or it would be the eccentricity divided by the inertia, okay. So we're in the area there, it is the pi over 4, the squared, or the d there is, it is the diameter, the c it is can be get as d over 2, and the inertia there, it is equal to pi over 64 a over 4. And then calculate its Q maximum and Q minimum. Okay. Before I forget this one, no? Please take note of those inertias, no? With respect to the triangle, with rectangular, okay, or semicircle, circle, quarter circle, and so on. Kasi it could help you, no, during your board examination. Kasi kailanganin talaga yan. And also, it is always na lalabas din sa solving ninyo in your steel and then in your reinforced concrete. Okay? So what if, the eccentricity is one way, okay? The ultimate bearing capacity under eccentricity loading has two types, no? The first type, it is the one-way eccentricity, and the second type, it is the two-way eccentricity. But we will not be tackling or we will not study the two-way eccentricity, no? Kasi it is not that popular, no? Kasi ang akin nililesson lang ay yun yung medyo popular sa ating soon na board exam. Okay? So, in this one way eccentricity, we will be asking to use the effective area method. So there are many cases or there are many steps on how to calculate the area method. Okay, for the first one, no, we would be determine the effective dimensions of the foundation. Effective, okay, it is not the dimensions lang. So, may term na effective na doon. Therefore, it is not the original dimensions of our foundation. Okay? For the effective width, okay, we will be using B prime. Okay? To solve for B prime, no, it is derived as B minus 2 times of its eccentricity. Okay? And for effective length, L prime, it is equal to L. Okay? So, the P prime that we will be using, it is in minimum, no? It would be a B prime or it would be the L prime. Okay? And for the L prime na gagamitin natin, it would be the maximum of the B prime or the L prime. Okay? If the eccentricity, okay, reacts or rotates in the axis of the L direction, okay, the effective width of that it is equal to B prime, which is equal to B. Okay? Lagi niyo tatandaan nito kasi mostly, no, it would help you during computation later on. Okay? And then for the effective length, okay, it is equal to the L prime, no? It is equal to the L minus 2 times of its eccentricity. Okay? So, kapag ang axis niya ay sa B, no? Ang ating gagamitin ay B prime is equal to B minus 2E, and for if the axis rotates on the L direction, L prime naman po yung mababawasan. Okay? Okay, yan po. The second one, we will be using the Terzaghi equation. For an example, for square footing, it is 1.3 QNQ, 1.3 CNC plus QNQ plus 0.4 gamma B and gamma. Okay? For strip footing, no, it is equal to CNC plus QNQ plus 0.5 gamma B and gamma. And for circular footing, no, it would be 1.3 CNC plus QNQ plus I think 0.3 gamma B and gamma. Okay? So the value of B there, no, sa last term, before the gamma there, magiging gamma prime. And then the B there, it would be the B prime, no, na gagamitin natin, na sinolve natin. Okay, not the original B. If, no, if the axis is on the B direction. Okay, but if the axis is on the L direction, so si L ang ating gamitin. So other factors in the equation will not change. The NQ, the N gamma, NC, the bearing capacity factors. Okay, hindi na yan mapapalitan. Okay, and if we want to use the Meyerhof equation, the longest, okay, or ano tawag dito? By using the additional factors, the shape factors, the depth factors, and the inclination factors, no? The B in the last term would be the B prime, okay? To get uniform pressure of these one, okay? And then the fourth one, if there is a water table, just like in the case 2 before, sa ating modification of water table, okay? We need the following equation to calculate the gamma. Okay, by using the gamma bar. Wherein gamma bar, it is equal to the gamma prime times dx times y minus y prime over b. Okay. For safety consideration or by using the factor of safety, okay, the factor of safety is equal to the Q ultimate divided by the Q allowable, wherein it should be greater than or equal to 3. Okay? If the maximum load, no, or the Q max is less than or equal to Q allowable, no? It is equal to QU over the factor of safety. And for the factor of safety against, no, by Q maximum, okay, the factor of safety is equal to QU, maliit, the stress, divided by the Q maximum, it should be greater than or equal to 3. Okay. If the value of Q allowable is equal or more than the Q max, ano ang gagamitin natin? Okay. So, titignan natin later on dyan. Okay. And if the value of Q min should be equal or more than 0, okay, ano yung ating gagawin? Okay. So, tignan natin later on during our computation. Okay. Do you have any questions with our discussion before we will go to the example number 1? May question po ba? Hello? May question po ba? Okay. For the first problem, no? If the soil is given below, okay, determine the allowable bearing capacity of an isolated rectangular footing 2 meters by 2.3 meters that's subjected to a vertical load of 425, no? So the applied load there, it is 425, and the moment, no, applied moment, it is 85 kilonewton per meter. By using the factor of safety, it is equal of 3. Okay? So the internal friction there, it is 20 degrees. The cohesion, it is 35 degrees. And the gamma dry or the unit weight dry of the soil, it is 16 kilonewton per meter cube. And then the depth of our footing, it is 1.5 from the natural grade line, no? And the groundwater is located exactly at the bottom of the footing, okay? And then the internal friction of that soil sa may part ni groundwater table, it is 25 degrees, and the cohesion, it is 0 because saturated yan, no? There is no cohesion for that, okay? And the gamma saturated, it is 19 kilonewton per meter cube. Okay? So, I will be discussing na lang to. We will not be one by one na tawag dito, isosolve. Okay? Kita nyo po ba sa screen niyo? So, this is the example, no? Ito na yung ating example number 1. Okay? By using the table, no, doon sa Terzaghi, table 3.3 if I am not mistaken, the internal friction, 25 degrees, has a corresponding bearing capacity. If cohesion, no, 20.72, and NQ, it is 10.66, and N gamma, it is 10.88. Okay? At tawag dito, speaking of the bearing capacity factors, no, I check some of kaka-start ko lang nag-check sa inyong assessment, learning task 1, no? And I can see, no, na you are not using the table, no? Kasi for an example, the NC there sa table supposedly it would be 20.72, but you are using 20.8. Okay? I don't know where you find that value. Okay? Wala naman sa discussion natin yung ganun. Okay? And then, yung NQ niya, naging 10 point, I think 10.6 or 10.7. Just like that, no? If you can see kasi, medyo may discrepancy na and then medyo malayo. Pag ganun. Okay? Okay. So, halata, if you are using that one, no, halata na you are depending, no, on the Google, no. So, um, hindi naman siya ganoon kalaking bawas, no, pero syempre, no, with due respect to to those who are using the correct solution, no? Syempre, may konting bawas lamang po sa kanila. Okay? And then, go on, no? Using the Q allowable, it is equal to the Q ultimate divided by the factor of safety. Okay? Hindi pa natin nasa-solve si Q ultimate, therefore, si 3 muna ang ilalagay natin. Okay? By using the Meyers-Hoff formula, okay? Kasi it is a mostly na yun yung gagamitin natin, okay? Si QU, it is equal to CNC, FCS, FCD plus times FCI plus QNQ, FQS, FQD, FQI plus 0.5 gamma B and gamma F gamma S, F gamma D, and F gamma I. So since the problem, no, at the bottom of the foundation is the cohesion has a value of 0. Therefore, yung ating first term na dito, yung CNC, FCS, FCD, FCI, negligible na to. Okay? Negligible na po yan. Okay? Therefore, si QU na lang po ay yung second term and the last term. Okay? By solving the Q there, no, yung kanyang effective stress, it is the gamma dry, no, times the depth of the footing. Okay? Siyempre, gamma dry ang ating ko-consider because doon nag-pass through yung ating foundation. Okay? Therefore, 16 kilonewton per meters cubic meter square, no, yung kanyang gamma times the depth of our footing, which is 1.5. So solving for that, no, kukuha mo yung 24 kilonewton per square meter. Ay, ito na. The effect of the eccentricity. Okay, paano po ba makukuha si eccentricity? No? As I have said before, no, eccentricity is equal to the moment, applied moment, divided the applied vertical load, the total vertical load. Wherein, no, 85 divided by 425, no, the eccentricity, it is equal to 0.2. No? So take note of this, kanyang eccentricity it is equal to 0.2. Okay. Ito naman. Si B prime is equal to B is equal to 2. And the L prime, it is equal to L minus 2E, which is equal to 2.3 minus 2 times 0.2, wherein the L prime there, it is 1.9. Question. Sir, bakit po yun ang ginamit natin? Okay. As you can see, sa ating problem, no? 2.3 po to. Okay. Bakit 2.3 to? It is the length. Okay. Length. Pero before sa ating foundation, no? Yung dimension na nasa baba, it would be the width. Okay? Any idea from the class bakit naging 2.3 yun? Hindi dapat hindi 2 meters? May idea po ba yung iba? Or wala? Mr. Archie, may idea ko po ba kung bakit 2.3 yun? Mr.
Sir,
Archie?
hindi po ba siya yung length ng gagamitin natin, sir?
Yes. Oo, length na talaga siya. Pero bakit, why na 2.3 yun? Kasi before, ang ating ginagamit is width. Okay? Bakit 2.3 na i-present niya?
Sir, Q-min po ba ata yung hahanapin natin sa case 1 natin, sir?
Ah,
Or hindi po pa ganun, sir?
kasi, ito na lang. Kasi, thank you Mr. Archie kasi ganun, you tried, no? Bakit 2.3 siya? Okay? Kasi sa given mismo, sa given niya sa word na doon sa taas niya, it is not stated, okay? So you will base, no, in the diagram or in the figure that is given, okay? 2.3 kasi the eccentricity acts, oh, okay, or it rotates on the L direction, okay, in the length direction, okay? Pero kapag 2 meters yan, yung nandito sa baba, yung kanyang dimension sa baba, 2 meters po ang nakalagay, and then it was stated that the eccentricity rotates or on the axis of the L direction. Huwag po kayong papamali na baka ang gamitin nyo is 2. Okay? Doon kayo magbase sa uh, binigay na instruction, which is 2.3 dapat ang gagamitin nyo. Okay? Nakuha po ba yun? Nakuha po ba? So kapag hindi naman po na sinabi sa problem, and you can see in the figure na the dimension for the length of the footing, no, 2.3, therefore it is a tawag dito, it is clearly stated na ang ating gagamitin na or the eccentricity is in the axis of the L direction. Okay? Therefore, no, ang kanyang B, no, if the eccentricity if the eccentricity is in the axis of the length direction, ang kanyang B prime, it would be the same, no? Kasi hindi naman doon umikot si eccentricity, no, there is no effect, okay? But yung kanyang L, no, it would not be the original length, which is 2.3, no? Mababawasan na siya ni 2 times the eccentricity. Therefore, si L prime na yun, which is 1.9. Therefore, in getting the effective area of the foundation, no, we will be using the new dimensions of the foundation, which is 2 times 1.9, and to get the 3.8 square meter. Okay? Okay. So, yung kanyang eccentricity nga po ay 0.2. Okay, the gamma that we will be using, the unit weight, which is equal to the gamma prime. Wherein, gamma prime, it is equal to the saturated unit weight of the soil minus the unit weight of the water, which is 9.81. Okay? Therefore, 19 minus 9.81, ang ating gamma prime, it is 9.19 kilonewton per cubic meter. Okay? Again, by using the what do you call that? By using the law of the Meyerhof, wherein we will consider the depth of the footing divided by the width of the footing, the original width of the footing, no? Yun yung which is equal to 1.5 divided by 2, wherein, no, the value of df over b, it is less than 1, no? If df over b is less than 1, no, our fqd, it is equal to our fqd is equal to 1 plus 2 times tan phi times 1 minus sine phi quantity, no, squared, okay, times the depth of our footing times b. Okay, and then solving for that, no, solving for that, it would be 1.233. Okay, And the F gamma D, okay, the F gamma D, it is equal to 1. Okay? And solving for FQS, no? If it is in the B direction, okay, yung ating FQS, no? It is equal to 1 plus B prime divided by L prime times tan phi. Okay? Yung B doon, no, kasi we will not be using the original value, okay? It is the new value for the B prime kasi nandoon na yung effect ni eccentricity. Okay? So kapag nasa B direction po siya, the numerator will be B prime over L prime. But for this problem, okay, it is in the L direction, wherein we will be using L prime over B prime. Okay? Uh, tawag dito? Lagi yung tandaan na kapag sa B direction siya, yung nasa numerator, it is B prime. Kapag L direction, the numerator would be L prime. Okay. Therefore, FQS is equal to 1.443. And F gamma S, no? It is equal to 1 minus 0.4. Okay. I have said, no? Kapag B in direction, B prime yung nasa sa taas. Kapag L direction, L prime yung nasa taas sa kanyang numerator. Therefore, 1 minus 0.4 times the quantity, 1.9 divided by 2, and then we can get 0.2. Okay? Solving for FQI, F gamma I, and FCI, no? Since it is not in inclined, no? The foundation it is not in the incline, or there is no inclination, no? The value for that F gamma I, FQI, no? It is equal to 1. Okay? So, by using the formula of Meyerhoff, then we will just input all the given datas, no? Or the solved datas, no? And then we can get QU, it is equal to 514.0878 kilonewton per meter square. Okay? And then Q allowable, it is equal to QU divided by 3. Okay? So, the QU there, it is 514.0878 divided by 3, no? We can get 171.3626 kilonewton per square meter. Okay? And then, Q max, no? We will determine the Q max, okay? It is equal to Q divided by P times L, okay? Times 1 plus 6E over L. Okay? The eccentricity is equal to 0.2. The L over 6 is equal to 0.3833. Therefore, eccentricity is less than to the dimension of L over 6. Okay? Ang ating Q max ay 425. The Q applied load, okay, divided by 2, okay, times 2.3. Okay, the original. Okay. And then 1 plus 6 times the eccentricity 0.2 divided by L. Okay, because yun nga, the eccentricity is in the axis of L direction. Okay, by solving Q max, no, we can get 140.17 kilonewton per square meter, wherein it is less than the 171 or the Q allowable. Therefore, we will consider the safety, okay, of our foundation, no? So we will be using the Q allowable, which is equal to 171. Okay. Sir, ano po ang importance why we consider the biggest one, the biggest number? Because we are tawag dito, we are considering its safety, no? Doon siya makakapasok yung inyong foundation, no? Kasi once na 140.6 no 140.6 no ang inyong maximum, then you are using 140.6, and then ang inyong allowable na load na i-carry ni ni foundation ay 171.36. Therefore, ang tendency niya, no, magkakaroon ng cracking, and then magkakaroon ng failure ang inyong structure or ang inyong uh, what you call that ang inyong foundation. Okay? So, yun yung kanyang kadahilanan na we would consider to solve the Q maximum there to get the allowable load that would be carry the foundation. Okay? May question po ba sa problem number 1? May question po ba? Hello? Do you have any questions? Hello po. How about the others?
Wala, sir.
Okay, I hope na wala kayo maintindihan kasi okay, tomorrow. Okay. I hope maintindihan ninyo kasi kapag may face-to-face na tayo, no, I will be giving your second quiz. Okay? And sana may isulat naman kayo sa quiz ninyo. Okay? So I will be leaving you the second problem. I will be discussing this one, okay? Tomorrow, before we will start the next topic for tomorrow, okay? So i-discuss ko muna ito because it is a an example, no, ng may eccentricity, no? Okay? Given na yung kanyang eccentricity. Okay. And then the factor of safety is based on the maximum value, which is 3. I think greater than or equal to 3. No? And then yung kanyang groundwater table, it is on the top of our footing. Okay. So read it muna. Basahin nyo na muna, and then I will be posting our topic for tomorrow. So ipopost ko na po siya ngayon for you to have a advanced reading. Okay? So yun lamang din kasi I will be going to school, no? Yun yung mahirap, no? Kailangan once na mag-start ang face-to-face, no? Kasi I think we will be allowed to enter during our laboratory time only, okay? And if we can see in our schedule, no? For an example, 7:30 to 9 our lecture, and then 9 to 10:30 it would be the laboratory. So it is hard to shift, no? Mag-shift ka kaagad, no? Kung mag-LMS ka during the first hour or the 7:30 to 9, and then papasok ka ng 9 to 10:30. So I don't think kung paano ko gagawin yun. Okay? So yun lamang. Okay, if you do not have other questions, wala na po ba talagang question? Before we will be leaving, wala na po ba?
Sir, tapos na pala yung solution, sir.
Pardon?
Yung
Pakilakas.
solution po, sir, tapos na po.
Yes, actually, this topic and the solution for this one, posted na po siya sa ating LMS. Ipopost ko na lamang po yung additional topic for tomorrow. Okay?
Thank you po, sir.
Okay, thank you. May katanungan pa po ba? Do you have any questions? Wala naman na. Hello, do you have any questions?
Wala naman ako.
Okay. Miss Mary Hanilin, are you there?
Sir.
Magpaiwan ka later kasi I have something to ask you, okay? So, if we do not have or if you do not have any questions, no, may I request Mr. Prince Jaylan Bakay for our closing prayer. Jaylan,
Yes, sir.
can you lead us in our closing prayer?